It talked about the energy efficiency, functionality, and performance requirement, and also about the energy efficiency label requirements. These was extracted from the same standard. What the standard, the requirements of the standard, the type of test, energy efficiency, functionality, endurance, and the existence of hazardous substances limitation. And also here on the right-hand side, the measured parameters, which has to be measured and issued in the report to get the energy efficiency label and the certificate from SASO. Of course, one of the most important criteria or features of the LED product, of any LED product, is the lifespan. I mean, that we all know that LED products have longer lifespan. So what you should have for your LED products of a lifespan at 50,000 hours at L70. What L70 means, lumen maintenance, 70%. When the lumen output reduces by 30% from the initial lumens. Color rendering, as we mentioned at the beginning, is color CRI should be not less than 80. Color temperatures between 4,000 and 5,000. Color consistency, that is as to have it as per three-step macadam ellipse, which will assure you that you will have a color consistency for your products from the same family in an open office space, to have a consistency and light in the color temperature and color rendering index. And one new requirement here, which is called blue light hazard group 0. This is as per IEC 62471. As you might know, how light is generated through the LED chip. All the LED chips, the light is generated as blue light, and they have lenses which convert the blue light into a visible light, white light. So when it is blue light, when it is blue LED chip, the light generated will be close to the UV spectrum. So there will be a risk of having some contents of UV radiation. So that's why now all the LED lighting, they have to comply to this standard IEC 62471. And group 0, that it has a minimum limit of blue light generated from the LED products. Look here at the Apple under different lighting with different CRI. This is the Apple at CRI 100, and see how it looks like with under CRI 70. This is the final topic of the presentation about the electrical power quality of LED products, which is important to the electrical engineer or the electrical design engineer when he design his electrical grid in the building. The electrical parameters which he has to consider in his electrical design. Of course, the first one, which is the power factor. All the LED products has to be with high power factor, and the definition of high power factor has to be more than 0.85. And the high power factor is required for products with higher than 15 watts. The second important electrical parameter here, which is the harmonic content. And this should be done as per the IEC 61000-3-2, and this standard gives the limits for the harmonic current emissions. And for lighting, they have categorized, they give it for 2 luminaire categories, between 5 watts to less than 25 watt. This is one category. And for luminaires with power of more than 25 watts. And we all know the harmful effect of high harmonic contents, because if LED product is an electronic product, so they generate harmonics. So these harmonics has to be well controlled, because I mean, the moment we generate more harmonics to the grid, there will be many problems, overheating to the cables, overheating to the distribution transformers, and so on. And this is extracted from the same IEC 61000-3-2. These are the limits for the luminaire categories, which is more than 25 watt. Where they give the maximum limits for all the harmonics. The most severe one is the third harmonic, where they allowed the limit to be 30 times lambda. Lambda is the circuit power factor. So if you have the circuit power factor as a high power factor, let's say 0.9, means that you are allowed to have a third harmonic of 27%. If the circuit power factor is low, 0.5, that you will be allowed only not to exceed 15% third harmonic. And for this category, between 5 to 25, the third harmonic is allowed up to 35%. The total harmonic distortion for this situation for luminaires of more than 25 watt as a code of practice, that it should not be should not exceed 15%. Okay, the last electrical parameter, which is the inrush current, as you know, that the power factor corrected products, how the power factor is corrected is by using capacitors. And by using capacitors, they generate transient or inrush currents. So my recommendation here is that the products, the power factor should be just between 0.85 to 0.9, not to exceed 0.9, because the moment it exceeds 0.9, the inrush current also will increase. So that will give you a limitation or a restriction to the number of products per circuit. And of course, each circuit will be connected to MCB, main circuit breaker. So you as an electrical designer should request this information from the luminaire manufacturer, where, see, this one gives you the maximum number of luminaires with a certain power. Let's say if your luminaire is 30 watts, okay, and you are using a B-type main circuit breaker with the rating 10 ampere, okay, so maximum number of lamps you should use about 10. Okay, so if the power is more, of course, the number will be less. And in this case, you will be assured that there will be no problems later on. There will be no circuit breaker tripping. Okay, finally, this is the conclusion and summary. As we have discussed at the beginning, that more light is not necessarily better. Light quality is more important than quantity. I mean, you can have an office, let's say an average of 500 lux, but the lighting environment there is not comfortable. and people will be complaining that it's not sufficient. Match the amount of quality of light to the performed function paired with the occupant age. Also, this is important that if you design a building to be used for young people, okay, and later on the client, okay, want to convert it and to be used for all people, that will not be sufficient. I mean, the lighting levels for the young people okay, are much lower than the required lighting level for the old people. Install task lights where needed to reduce ambient light elsewhere. Use energy efficient lighting components and control systems. Maximize the use of daylight, implement of daylight sensors, enable dimming, we have discussed that. Use energy efficiency labeled lighting fixtures. And this is a sample of the energy label, okay, by SASO for each lighting product. And as similar to the energy label of the electrical appliances, when it falls here, that it has the highest and optimum energy efficiency. Okay, when it is on the red color, means that it's no longer an energy efficient product. And finally, use occupancy sensors for automatically turning off and off lights as needed. Now this comes to the end of my presentation. Now I'm ready to answer your questions if there are. I don't know if someone has sent questions. I don't see questions.
Mommy.
مساء الخير محمد.
على حسني.
يعطيك العافية. We thank you for this presentation. We appreciate it. And thank you for all the valuable information that we got. First thing, could you share with us this presentation?
Yes, sure. You have my, for other guys, you can see my email here. You can just drop me an email. Okay, I will be sharing this presentation in PDF format. No problem.
Thank you very much for that. Sure. Another thing, for blue lighting hazardous group 1, the IEC 6241, do you have this article?
471, 62471.
6241, okay.
471.
Okay. Do you have this articles with you or?
The standard?
Yes.
Yes, I have that. But this is in a standard, a SASO standard, which I cannot share. I mean, you have to get it through SASO website.
Okay, thank you.
Welcome.
The last question is when you are calculating or you recalculate, you said at the task, the best practice is to use at the task surface the 500 lux,
yes,
which is recommended by C. Now, when you use the pendant light, I saw in your calculation is 350. Is it only the task under the task light without the down light?
Where did you see 350?
350 when you use the your recommendation to use the pendant light. If you go back to that slide.
So maybe yes, you can have this 350 in between the desks. But on the desk itself, you will be we achieved the 500 lux. So
I have seen, I don't know, I have seen 350. Maybe it's my eye.
Yeah.